Hello, this is Phil Thomas, New Era Systems. Today we're going to do a quick show and tell on quite an old amplifier. This is a 10999 from MCL, and even though it's a few years old, it is in remarkably good condition. We've just taken it out of a Wolf broadcast trailer that we received a couple of days ago, and we're going to upgrade the trailer with a much newer pair of amplifiers. And so we took the opportunity of putting this one on the bench and testing it. There's another one just like it, is identical. Even the test results were close. And if you want to see the test results, they are on our website. But of course, this is October 2018. If you're looking at this video in 2019, the chances are the amplifier has been sold, and so it's no longer on the website. But anyway, let's take a quick look at the components. You can see the amplifier itself. It's got a lot of switches, but the nice thing is that it's easily controlled. With some of the other amplifiers, you have to go to dip switches to get cathode voltage or the helix current. Here, all I have to do is change this switch and I'll get a readout there. Now, on top of the amplifier, there is an Agilent power meter. The power meter is connected at the back to a waveguide coupler on the flange, and you're going to see different outputs. The power meter is going to show a lower output than the display on the front of the amplifier. That's because the amplifier display is working actually within the amplifier itself, probably at the exit of the tube, whereas the power meter is taking a measurement where it really matters, at the flange. You can get a better look at the crossguide coupler and the dummy load. And of course, as everyone in the industry knows, if we're static testing these amplifiers, we have to have a dummy load on the back to absorb the radiation that's being produced by the amplifier. I forgot to mention, this is a 300 watt TWTA. It has the power range of 14 to 14.5 gigahertz. The other component that we're using for the test is this frequency generator. Currently it's set at 14.25 gigahertz and the RF is off. We tested the combination of the amplifier and the frequency generator yesterday, and so I know that the setting on there of 25 dBm is just about at the max of this amplifier before it goes into saturation. And so that's what I'm going to do. I'm going to fire it up now. I'm going to give it quite a few minutes to get up to temperature. And then I'm going to flick on the output power from this frequency generator. Okay, we've got it warmed up. Now, if you look at this front display, you can see the output is showing at 0.04 milliamps. This is the measurement of the helix current without any drive. We normally measure the helix current in 3 different places: no drive, low drive, medium, and saturation. And with those different measurements, we can get a very good idea of the health of this tube. So what I'm going to do now, I'm going to turn on the RF. Okay, so now and turn it to transmit. Okay, it's transmitting now. You can see 2 different readings. The power meter is showing 110 watts, which is where it should be. But on the display of the amplifier, it's showing more. As I discussed earlier, it's measuring at a different place. Now, I'm going to increase the power a little bit on the frequency generator, because I know that from our previous test, this is going to max out at somewhere around 210, 220 watts. Okay, we're running up to 168 now. Okay, we're running at 205. As I said, from our test yesterday, we know that this is pretty well reaching saturation. There's a few more watts to be squeezed out of it. But again, look at the difference. We're showing 255 on the amplifier's display and 205 actual on the display coming from the power meter. Now I'm just going to look at the helix current, and the helix current now is showing 3.65 milliamps, which is extremely good for a tube. Tubes range all over. Some of them can even run up as high as 8-9 milliamps before they are in trouble. But normally we'd like to see a tube running at probably less than 5 or 6 at full power. And so this one running at less than 4 is extremely good. Even though this is an older tube, my guess is that it probably hasn't been used that much. Okay, that's it. As I said, it's a brief test, it's a show and tell. So I'm going to wrap up everything and see you on the next video. Thanks for watching.